Okay. Sorry, I had a student that came in. All right, so we're back on this one, and you would need absolute values on this one because you're taking it from a squared, and you need to make sure that is a positive. Okay, so we come over here. I'm down on number 7 here. We're going to write it underneath one big one. And again, you don't have to do all this little extra writing with it, but we can. So on here, 3 goes into there 16 times. That goes into there twice. All right. And then here we're going to leave the y squared on the bottom. And we got a big square root over all of this. All right. So what's the square root of 16? 4. You're going to take the square root of x squared. So we divide it in. And we get your x. You're going to take this one, you're going to divide it in, and you get a y. All right. Now again, we should probably do the absolute value on the x, absolute value on the y. Okay. And really, originally, I don't feel we need the absolute values on the x. Maybe we shouldn't, because it was originally to the 3rd power to begin with, so maybe it doesn't matter. All right, so let's go over here. Okay, we'll break the 20 down into 4 and 5. So I'm going to break that down into the square root of 4 times the square root of 5, and then we have our square root of AB. I'm just doing this one a little different. The square root of 9 times the square root of 5 times the square root of a squared b to the 3rd. All right. These divide out, and this becomes a 2, that becomes a 3. So we have 2 and then the 3. I'm curious where they're gonna go with this one. Here you're going to, these will divide out. You'll be left with a on the bottom and a b squared here. Okay. We kind of jumped the gun on this one a little bit. I can do the square root of b, so you get 2 over 3. The square root of a stays, but the b is going to come out here, and you really should have absolute values on that. But again, it was odd up here, so you don't have to. Now, in a moment, we're going to talk about rationalizing this denominator. So for right now, that's what we have, but that a does not belong on the ground. So the true finished answer is this. And I'm going to explain why in just a minute, because you can't have a radical in the bottom, and that's what this all talks about, is rationalizing the denominator, and shows you how to take care of it. So that's what I mean by they jumped the gun. That answer you need to rationalize, and we had not learned that yet. Okay, so I'm going to go through a basic example of rationalizing the denominator before I get into a more complex problem. We did this back in math too. If we had 6 divided by the square root of 3, you cannot leave a radical in the bottom. So how to fix it is you multiply both sides, the top and the bottom, by the square root of 3. All right, this is really just the number 1. So you're multiplying by 1, you're not changing the problem. Well, 6 times the square root of 3 is 6 square root of 3. Square root of 3 times the square root of 3 is 3. You get the square root of 9, but the square root of 9 is 3. So your whole point was to get rid of the radical in the bottom, which we did. All right, when you multiply 2 radicals by itself, you get what's underneath. Well, 3 goes into 6 twice, so your finished answer to that problem would be 2 square root of 3. All right, so this is called rationalizing the denominator. Getting that radical out of the bottom is called rationalizing the denominator. All right, so on this one, we have the cube root of 7x, nothing can break down, and we have it over the cube root of 5y squared. All right, so nothing can break down here, and I can't leave the cubic in the bottom. So this is just kind of a thinking game on this one. What can I multiply a 5 by to get to a perfect cube? Now your perfect cubes, you have 1, 8, let's see, 64, that's 1 times 1 times 1, 2 times 2 times 2. Oh, I need 3 times 3 times 3, that's 27. 4 times 4 times 5, 4, 5 times 5 times 5, 666. I think the next one might be like 343, that's your sevens. All right, so what could I multiply a 5 by to get to one of these? So this one catches my eye. And I get to 125 by multiplying 5 times 25. So I'm going to multiply by the cube root of 125. Now, it would be really great if this was a y to the third, because if it was a y to the third, then 3 would divide into it evenly, so I need another y. All right, so whatever I do to that, I need to write on the top as well, because we have to keep it consistent. All right, so up on the top now, you're going to multiply that across, and you are going to get, what is 7 times 125? So let me think. 7, 4, so 875 maybe? Oh, I just need to, oh, hold on a second. No. I want to multiply by 25y, not 120. I want to get 125, but I need to multiply by 7y. So reverse. Sorry. I'm backing this up. I need to multiply by the cube root of 25y. Multiply by the cube root of 25y. That's what I want to get to 125, all right? My brain, I don't know what happened. Anyway, so up on here, on the bottom, I'm going to get the cube root of, I don't know why that keeps blurring. I'm going to get the cube root of 125 y to the third power. All right, up on top now, I'm taking 7 times that, which is 175, and I'm going to get yx. So the cube root of 175 and xy or yx, it doesn't really matter. So this is what I have right now, and that's all under, okay. So what I'm going to do now is the cube root of 125 is 5. If I divide my y to the third by 3, I get y. I'll stop that from doing that. And then on the top, I have that cube root of 175 xy, and that will stay on the top. The cube root, it's okay to have a radical in the top. You can't get rid of everything. Okay, so your finished answer is going to look like that. That is your rationalized denominator. All right, so I look down here. And I'm going to go ahead and see what I can do. Well, the x's are going to divide out, and I'm going to be left with 1 y in the bottom. The 2 of the y's at the top will divide out with 2 in the bottom. All right. So I'm going to get 3 on the top, and on the bottom, I still have that 5, and I'm going to be left with 1 y. All right, again, I can't have this in the denominator. All right, so what I'm going to do is rationalize the denominator. So I'm going to multiply by a 5 because that will get me 25, which is good. I'm dealing with square roots this time. And I need 1 more y to make it a y squared. And again, what I do to the bottom, I do to the top. So on the top now, I multiply these across. I get a 15y. On the bottom, I get 25y squareds, but that breaks down into my 5y, which is the whole point of doing that. Okay, was to get our radical out of the denominator. And that's what I would end up with for that one. All right, here, I can go ahead and divide the 12 and the 10 by 2. So I'm going to get cube root of 6. My a's looks like 1 here, 1 down on the bottom. All right, let me do them both here. So I'm going to get a 5 divided by 2. My a in the top divides out with 1 of them in the bottom. All right, so I don't have any a's up here, and I'm going to have an a squared down here. My b in the bottom will cancel with 1 of my b's up here, so I get a b squared on top. My c in the bottom cancels with 1 c here, so my c's gone out of the bottom. All right, now I have to think. I'm dealing with cubes again. What can I multiply a 5 by? We just went through this. What can I multiply a 5 by to get to a perfect cube? So I'm going to multiply it through by a 25 to get that 125. I need to get this up to a power of 3, so I just need 1 more a. And again, what do I do to the bottom? I do to the top. All right, so on the top, I'm going to multiply across now that I have the same index. 6 times that is 125. A, b squared, c. And on the bottom, when I take the exact that times that, I'm going to get the cube root of 125 a to the third, but the cube root of 125 is 5, and 3 divides into 3 one time. So there's my finished answer for that. All right, so it just takes a lot of organization. Slow yourself down. There's more than one way to do these problems. So if you're a little confused with one of the steps, you know, if you forget to divide over here, you know, divide like the 12 and the 10, not a big deal. You'll just end up having to do some more division when you get over here. All right, and I will put the homework on Google Classroom.